Welcome to Introduction to Statistics and Research Design. My name is Carlos Vargas and I will be your instructor through this course. We'll get to work a lot through this course online. You'll get to see me through the screen, so at least you have an idea for who will be behind the screen. I may not have the chance to see you, but we'll get to know each other a lot through this course as we will exchange information back and forth over and over again. This is a class that I'm very excited to teach. I have not taught statistics through a whole long course. I did it last semester as it was due to the unexpected situation of COVID-19. But I'm ready for the challenge, and I hope that you guys will have a good experience through this course overall. There's a couple things that I want to tackle on this first video. So let's get right to it. First thing is, this is a class in the realm of psychology and in the context of psychology. So what is psychology? In case you don't know, this is the logo for psychology. And psychology is pretty much, simply said, the study of mental processes and behavior. Key words there are study. We study mental processes, we study how behavior works. And interestingly enough, when I came in my first semester as a student, and I began to take my classes in psychology, I had no clue that I would encounter a branch in statistics. And most psychology students honestly get somewhat dumbfounded, get somewhat confused by it because they didn't expect it. But the reality is that the statistics is an important branch in the study of psychology. So the question is, why statistics? Let's talk about that, you and I, through the semester, through this course, I'm sorry. Statistics is a branch within mathematics that allows us to understand why mental processes act in a way, why behavior works in a way. If I have an interest in knowing how memory works, I need to collect data. To create a good study that would allow me to objectively understand memory, I need to collect data from a group of people, and I need to gather numbers from those group of people that will allow me to then, in a more objective way, tell what is going to be the outcome. Statistics allows our observations to be fair, to be reliable. This branch of study allows all of us in the field to know that any study that comes out there is information that we can actually use because it's fair and it's reliable information. A branch of statistics also will provide for you very valuable skills. And here's the thing, when you study in psychology, overall you take two different types of lessons. You're given a lot of information on what is content psychology. If you have taken a class on Introduction to Psychology, on Social Psychology, on Personality Psychology, those try to teach you how the mind works, those try to teach you how behavior is like, and that's all content. But in the field of psychology, we also try to teach you skill. So skills specifically are used by the time that you get into the field. If you take a class in abnormal behavior or in clinical psychology, they teach you how to observe behavior so you can conclude if someone has some type of a mental illness. That would be a skill. If they teach you how to properly make observations so you can give a diagnosis, that's all skill. So there's a difference between classes that are just giving you information, which is content, with classes that are teaching you how to do things with the content that you receive, and that's skill. Statistics is a class purely, or more, not purely, but primarily based on skill. So I will teach you skills that you can use and will make you more marketable by the time that you go into the field. If you want to make a career in psychology, content will not be the only way for you to make a living. Skill is as well. So this is important. Look forward to it. There's a lot of value from the information that you will gather in the semester, and realize, by the way, this is an introduction, so I will teach you the basics. Cool? Now, let's talk about the big elephant in the room though. I've taught this class many times before, and the main thing that I noticed is, and also happened to me when I was a student, Approaching the class with fear about math or anxiety about math is well understood, and it has validity because there will be some math involved in this course. The math is one component, but it's not the only component. This class will not only teach you how to do computations, but I will strive hard also to teach you what's the point of the computation. You really want to make a mental note about this. It's not only about knowing how to do something, but it's also knowing what is the purpose of doing that something. So, in our class, it will be not only about teaching you on skill, but also what is the purpose of knowing that skill. So, quick note. In regards to mathematics, it's very simple. And I have uploaded for you a math review. It's a PDF file. It's like 15, 16 pages long. Some of you may be quite skilled in the basics of algebra, so you don't maybe just glance at it and know how it goes. In case you don't, everything that you see in that PDF shows you step by step what we will need to know about math for this course and for you to be successful in this course. If at any point you get stuck on anything, by all means, you can always reach out to me and you can always ask me questions about it. Make sure that you stay continuously in touch with me, The main things that you need to know as far as the math review, main things is the order of the computation, which is also at the end of the PDF that I gave you. Make sure that you review that, make sure that you follow along and you do the first homework correctly, and I will give you feedback. You'll be fine. It's not too much math. And of course you can use your calculator, but at least of the first weeks of the semester, I will give you a lot of problems that you will have to do by hand. At least I want to see the effort by hand, because I do want to help you guys to know what are you thinking, how your steps are, what is the process behind it, and so forth, so then you understand how this goes. By the end of the course, I will show you how to do those things by computer as well, so it will be a well-rounded approach into learning for this. Okay, now let's talk just a little bit about the main highlights from the first lecture. I want to briefly just give you an introduction over statistics overall in that first lecture. And one of the first things that I wanted to know is the difference, and this is very important, among inferential and descriptive statistics. Within the branch of statistics, there's two different types of statistics. Descriptive, like the name implies, is describing the information. If I gather information from a group of people, I take off data such as, say, their average age. If I'm interested in knowing how many hours they spend watching Netflix over the quarantine, okay, I'm gonna collect all their hours and get an idea for how many did they, on average, watch. That would be describing the information. In essence, descriptive statistics are just trying to paint a picture with numbers for all the people that you try to study. That's descriptive statistics. About half of this course, a little bit less than half of this course, will be based entirely on descriptive statistics. By the time that we start to talk about frequency distributions, about measures of central tendency, about measures of variability, and even about normal distribution of z-scores, all of that is going to be descriptive statistics, and you will get to see them as the course moves forward. In the second half of the course, we'll start to talk about inferential statistics. Inferential, like the name implies, tries to infer information, tries to deduce information, tries to conclude information. Inferential statistics, for example, is when you get to groups of people and you try to compare them to see if there's a difference among one group with the other. Perhaps you're interested in knowing how many hours of Netflix were watched before going to quarantine versus after going to quarantine. So you're trying to make a comparison of two groups. That's going to be now an inferential statistic. You're going to try to make a comparison to infer if one thing is causing another. Very important, you'll get to learn about both. So half of the course will be about descriptive statistics, half of the course will be about inferential statistics. The other thing now is about research designs. There's different ways in which you can collect information for a study. Alright? Some of the information that you can use to collect some of the ways that you can collect information for a study. You can establish a survey. You can observe people and take numbers. You can find for correlations, which by the end of the lecture, by the way, I put up some major flaws within correlations. Watch out. But the main thing that we'll study in this course will be about experiments. So, an experiment tries to find a cause and effect. In an experiment, very, very important, you're trying to control factors. You try to control all factors so you can prove that one thing causes another. If you took introduction to psychology, you may have seen this before, so maybe somewhat repetitive. An experiment tries to control all variables so you can check if one thing causes another. And very important to know the difference and the distinction among independent and dependent variables. When you try to control all factors, I'm interested, right now there's a big deal going on at the time that I'm recording this video about trying to find a vaccine that works for coronavirus. So, let's try to create a vaccine that will help out with this disease. What we can do is controlling all variables, try to find if specifically one specific chemical is going to help out to control, reduce the symptoms. This chemical is going to be tested against other chemicals, and that chemical is the one that is independent, is the one that I'm trying to manipulate. And the dependent variable is what my main interest is. In this case, I'm trying to see if there's a reduction of symptoms or if there's a cure for the symptoms of coronavirus. So that's my dependent variable. I'm trying to measure by manipulating. The manipulation comes from the independent variable by changing one variable to see if it's going to change the outcome on the other one. The dependent variable is the result that I'm interested in. If I want to establish a study and I cannot realistically take the whole population to study, what you do on the sciences is that you get a small group within the population, which is your sample, and the idea is that what you try to understand on the sample, you try to generalize to the population. Say that I'm trying to create a new type of therapy that will help with people that are going with depression, experiencing depression. I cannot just take all random people that are suffering from depression. What I can do is go perhaps to a clinic, try to get a small group of people that are suffering depressive symptoms, try my new method, and if I find good results, then what I understand in this small group of people, maybe I can generalize to the whole population. What you try to understand in the sample, you try to generalize to the population. Now, the last thing that I want to discuss is in regards to scales of measurement. All of this information is in the slides, by the way. Here, the only difference is I'm trying to explain them in my own words, but it's the same information that you have in your slides, at least for this first video. So, in regards to the scales of measurement, this is in essence what kind of data are you working with. It depends on the kind of data that you're working with, is the type of statistics that you will use. This right now is important to know as far as a foundation, because it will become more and more relevant as the course goes by. And if, say, by the third week of this course, I start to talk about interval data, you don't want to be left out saying, what do you mean? Have an idea for what the scales of measurement mean. So, the kind of data that you will get can be nominal data. So, nominal is saying that all data is different and there's no way to quantify if one is more than the other. For example, nominal data could be names. Nominal name. So you cannot say that one name is bigger than the other because those are not numbers, those are names. That's nominal data. Nominal data is just showing you that there's two different categories, but they're not telling you that one is more than the other. Ordinal tells you one is more than the other, but ordinal, think of order. Telling you one is more than the other, but it's not telling you how much is the difference in there. So for example, order in a race. If you run a marathon, there's first place, second place, third place, there's an order. But maybe between first place and second place, there was like a 5-minute gap. But between second and third place, there was only like a 40-second gap. So knowing the order doesn't really say how much close was it or how big was it. It's not quantifiable to know how big is the difference. It's just telling you there's a difference in the order. There's a difference in the order. That's ordinal data. To know quantifiably how big is the data, then is when you go into the interval. So interval is putting up numbers that can be measured as far as giving you twice the size of something, or what is something divided by half. Typically, in essence, interval and ratio is the same thing. Ratio is also the same thing. Quantifiably can tell you. So for example, what is weight? Say somebody is 200 pounds in weight and somebody is 100 pounds. You can say quantifiably 200 pounds is twice as much as 100. That's quantifiable data. That's a ratio. What makes a difference among ratio and interval? Interval does not have a zero, a true zero. In ratio, a zero means nothing. There's nothing there. You cannot go below zero. But with interval, you can go below zero. Best example is always temperature. If you try to track temperature, say for example in Celsius, you can go below zero. If you cross to Juarez, they take temperature in Celsius there, and when it's December or January, when it's the winter, you know that if you go below zero means that it's pretty cold. But you can go below zero, you can go -10. With ratio, you cannot go below zero. So it's zero, that's it, and that's nothing. So don't worry too much about the distinction in interval and ratio, because in essence, most of the studies that we'll do, most of the examples that we'll work with, will be with those two, but I'm not going to make that much of a difference. But I want you to realize later on, I will give you an introduction into types of measures that are specifically used for nominal or ordinal, but wouldn't be used with interval and ratio. So it's giving you a bit of a basic foundation for that. That would conclude the first video, the first lecture, hopefully not too long. And again, if at any point you have any questions, especially in regards to the computation, which is the first homework, let me know as soon as possible. All right, well done.